All right, kids. Here we go. As promised, here's a little video to kind of get you through the day without me here. So I need you to turn to page 28 in your little packet. And there's a few questions here that I've made up so that we can take a look at writing absolute values as piecewise functions. There's two things that we're going to do. We're going to do this, and then I'm going to go to an activity at the back on page, I think it's 35. So this should take about 15 minutes or so, and then I'll give you a couple exercises to do, and it should set you up for the day. So here we go. Okay. So if I graph f of x is equal to the absolute value of x, I think everybody by now better know that I'm going to get a graph that looks something like this. Okay. I'm going to have a slope of 1 in the positive direction and a slope of -1 for when x is less than 0. And if we take a look at this, like, we can really break this up into two lines, right? Okay, so I can make it into a piecewise function. So if I started from the left, okay, I can have one function that I'm going to see for x is less than 0, okay, which is going to be, what does this line look like? It looks like -x, right? Okay, and as I keep going this way, I'm going to see for when x is greater than 0, and it doesn't matter much where you put the equal sign here as long as it's only to one of them, so I'm going to put the equals there. I'm going to see what line is this. It's the line x. And that's the essence of what we've got to do. Anything that's on, I'm going to break this absolute value into two pieces, and for the negative part, or the negative arm of that absolute value graph, I'm going to make it what was inside the absolute value negative, and for what was on the right hand side, or the positive part of the absolute value of x, I'm just going to leave it positive. Okay, so let's try it with a little bit different one. This is kind of a nice way to take a look at it, is to say, okay, look, what's my anchor point to my absolute value? So it's going to be -3. My translations are going to take me 3 to the right and 4 up. So here. Okay, and then I've got the same, it's the same picture as this one. So I'm just going to draw with a slope of 1, +1 to the right of it, and -1 to the left of that translation, the anchor point that had the translation to it, right? Okay, so something that looks like that. All right, now, two lines, so that means I can turn it into a piecewise function. So f of x is going to equal, and just like we did over here, I'm going to make what was on the inside. Okay, so my translation, my horizontal translation took me to +3, right? So for when x is less than +3, okay, so for all of these numbers, I'm going to put in the negative part of the absolute value on the inside, and then still the translation of +4 stays the same on the outside. Okay, and that's the equation of this line. And we'll simplify it here in a second, but that's basically it. Okay, so on the right hand side, it's even easier. I just take the horizontal translation, keep it the same, no negative now, right? Because this is the positive side of the absolute value, and it's been translated up 4, and I'm going to see that for all of x is greater than or equal to 3. So let's check our answers here. I can reduce this so that I'm going to distribute the x, the minus through the parentheses here and add the 4, and that's going to give me -x minus 1 times -3 is +3, plus 4 gives me +7. Okay, so again, that's for x is less than 3. Well, let's see if that makes any sense. Look at where my y-intercept is. When x is 0, y is +7 on that negative arm. So I know that this is working. And on the second one, it's going to give me x minus 3 plus 4 just gives me x plus 1 for x is greater than or equal to 3. And I think everybody can see, like I don't want to see this on my piecewise function because it splits off at the 3. But if I continued this little part of the piecewise for this line, it would take me to a y-intercept of plus 1. So I know that this is the true piecewise function of this absolute value. Okay, I can't do much more with those for you except make the transformations a little bit more difficult. So here's a couple to try. I'll give the solutions to the substitute teacher that you're going to have, and you can check your answers with them, and I'll post them online as well. So try a couple of those. No big deal. Okay. Those are coming up on the quiz and the test. So it's just a little detail that we got to knock down before we write those. Okay. Being turn over to page 35 now. Okay. I just wanted to go through one of these piecewise functions again, and then answer a few questions based on what they've done. So if you could go ahead and draw this piecewise function now, that would be awesome. So you guys go do that as an exercise, and then we'll start to talk. Actually, I'm going to do it. I'm going to do it with you here. So look, for x is less than minus 6. All right. That is, for all of this, I want to see 5 over 3x plus 6. Okay, so I'm going to put negative 6 in. Okay, so 5 thirds times minus 6 plus 6 is going to give me, looks like minus 10 plus 6 gives me minus 4. So at minus 6, I'm going to get minus 4. And that's going to be an open circle, right? Okay. And then I'm just going to go to the left of that and pick another point that's going to maybe work nice. So if I want to divide by 3, maybe minus 9 would be a good one to choose. Okay. So I'm going to do the same thing and say 5 thirds times minus 9 plus 6. So now I'm going to have these two cancel out. Give me minus 3. Minus 15 plus 6 sounds like about minus 9 to me. So if minus 9 goes in, minus 9 comes out, and I get this straight line that goes off in that direction, right? Okay. Next, when x is equal to minus 6 at this spot, I've got a point that's 5 high. So I can put that there. And here we got a little bit of work to do because I've got to see the right transformations here. So I'm going to rewrite this one as minus, and I'm gonna take the minus 2 out on the inside. Okay, and that's gonna leave me with x minus plus 2, right? No, x minus 2. So let's check and see if that's right. I've got minus 2x plus 4. Yep, looks good. Okay, so I know that this is going to be a root sign. Okay, that's flipped over each axis, and it's going to have a stretch here. So the best way to go with this might be just to plug in, okay, to see where the 6 and where the 2 comes out. So if negative 6 goes into this, I'm going to get 12, 16. Square root of that is 4. So I'm going to get minus 2 or minus 4 there, right? So, oh, looky here. It's the same point. Okay? And that's for when I've got to leave it open because it's 6, it's open, but I know it's coming up to this point. okay? And if I put 2 in over here, okay, I'm going to get, looks like 4 minus 4 gives me 0, so the square root of 0 is 0, and that one's a full point, which looks pretty good, okay? So if I knew that that one was originally a square root sign with the anchor point at -2, okay, and so it would have flipped this way and this way, I know that I've got a graph that's going to come through something like this. Oh, sorry, that's supposed to go up at 2, right? That 0 is supposed to be here. Not at 0, but at 2. There we go. Okay, so I've got a point that comes down. Okay, so at about a -1/2 there. And when I go 1, 2 over, I should have one that goes there. So something that looks like that. Okay, so long story short, it was here, okay, before the flips. Flip once, flip twice, right? Okay, so the 2 minus signs are done there. So that one's good. Okay, and then the last one is simply a parabola, x squared plus 5 for when x is greater than 2. So, or sorry, x squared minus 5. So -5 is down here. Okay, this is where my anchor point would have been. Okay, and so 1 over 1 up, 2 over 4 up, 1, 2, 3, 4, and that's open. Okay, and then let's do another couple points on the parabola. Like I only want to see what's on the right-hand side of 2 here, but this is still my anchor point, right? So here would have been my parabola. Here, here, 2 over 4 up, 3 over would give me 9 up. So that takes me to there. Okay, and then the parabola that I would have seen, and I guess, do we have enough room for 16? No, we don't. Okay, my parabola is going to look something like this. So I would have this part in here, but the part I want to see is simply this. Okay, so I can erase this part out. All right, so that looks good. That's my function. Okay, so let's, it says intercepts first here, but let's deal with the domain and range. Okay, so is there any place where the curve doesn't have a function of x? Do I have to make any domain restrictions? So it looks like if I put any number from when x is less than -6, it's going to be on this line, so that's all there. At 6 exactly, I've got a point up here at 5. And then in between -6 and 2, I've got the root sign. So there's always going to be something there. Okay, this is a closed circle at 2. So there's something right at 2. And then for anything after that, I can put any x in to the right of 2, and that's going to be on my parabola. So my domain is x is the set of all real numbers. Okay, the range, let's take a look at that one. If I start down here at -infinity, okay, it looks like I'm going to have something everywhere except, at -4, because I've got an open circle there. It doesn't look like there's any value at when, or x value for when x is, or for when I've got at -4. So at -6 and 4 here, right, for a height of -4, there's no graph. Okay, and I think every place else there is some graph. So my range here is y is the set of all real numbers, except y cannot equal -4. Right, so that's good. Okay, let's go do the intercepts now. So for my y-intercept, okay, and here we just have to kind of be careful of like what domains we're looking at here, right? So I can see my y-intercept is obviously where x is 0. Okay, so I'm looking for a point that looks like this. So you have to look into here and say, well, when is x equal to 0? Which place does it belong to? And it belongs right here, right? So if I plug 0 into here, what am I going to get out? It looks like I'm going to get -2. All right. My my x-intercepts, it looks like I've got 2 right here, right? That's where we cross the x-axis. So that's when our y is going to be 0. Okay, so for when our y is 0, it looks like I'm going to have to go and find, it looks like this one's on our root sign, right? So when is that y going to equal 0? Okay, so all of that's going to equal 0 when x is equal to 2. And for the other one, this is part of the parabola, right? So I'm going to have to make, well, here, I got to do this first. So I said for this one, I'm going to make minus square root of 4 minus 2x is going to have to equal 0. So the square root of 4 minus 2x is equal to 0. Multiply negative by both sides. Now I can square both sides. 4 minus 2x is equal to 0. So it looks like 2x is equal to 4, and making x equal 2. Okay, that's kind of how you figure that one out. Okay, and then the other one, x is 0. Now which curve is this y-intercept going to be on? It's on the parabola, right? So I'm going to go ahead and I'm going to make x squared minus 5 equals 0. So I'm going to get x squared is equal to 5, and x is equal to plus or minus square root of 5. Okay, but here you got to be careful because we can only use the places where this curve is part of the piecewise function, right? And it's only good for when x is greater than 2. So I can only use the y-intercept of plus square root of 5. Okay, because the square root of negative 5 is over here someplace, right? And it's not an x-intercept there. It's not part of the domain of this function. Okay, and just a couple more here. So let's do some values. F of 6. Let's see if we can fit this all on the same page here. Looks like we can. Okay, F of 6. Well, where does 6 belong? 6 belongs with the parabola, right? So 36 minus 5 is equal to 31. Does that make sense? If I was way over here at 6, could you imagine the graph going all the way up to 31? Sure you could. Okay. Minus 2. Which domain restriction does that belong to? I think that's this one, right? So I'm just going to say f of 2 is equal to negative square root of 4 minus 2 times minus 2. Okay. Which looks like that equals the negative, I don't know, square root of 8. That looks okay. Or if we want to simplify it, negative 2 roots of 2. Okay, so at negative 2, it looks like we've got 2 and a little bit, or maybe 3 and a little bit. Yep. So here. And f of 2, where does that one belong? F of 2, ooh. F of 2, well, which one does it belong to? Does it belong here, or does it belong here? I think it belongs here because of the equal sign. Okay, so I'm going to dump 2 into this again, negative square root of 4 minus 2 times 2. Looks like it gives me 0. Okay, so when 2 goes in, 0 comes out, and that makes sense because that's where our curve is defined, right? And last but not least, f of minus 10 is going to go into this dude here because minus 10 is less than negative 6. So I'm going to go 5/3. Now this is going to be a little ugly. You got to do a little fraction work here, right? Times minus 10 plus 6. So let's work through this. That means I've got minus 50 over 3 plus 16 is the same as 18 over 3, which gives me, what's that going to be? Negative 32 over 3. This looks all right. Okay. And now it's the last question down here is asking, so does that make sense? Let's see, negative 10, 32 over 3, 3 goes into 32, I don't know, 10 and 2/3 times. Looks almost exactly right, even though I freehanded it. I'm just that good. Okay, and last but not least, let's see if we can fit this in. Where is f of x equal to 4? So what we want to do is we want to know when our function, all of this, is equal to the height of 4. Right, so here, let's just zoom out a little bit. Okay, so we want to know when the height of the whole function, this, is equal to 4. So I'm going to draw a little vertical line here, or sorry, horizontal line here, and I can see which part of the graph I have to make equal 4, right? If it's at the height of 4, it touches this one and this one only. So it's the parabola that I have to go and find that value for. We're trying to look for this, right? So let's go and say that 4 is equal to the parabola part, x squared minus 5. Okay, so now x squared, we solve for that, is equal to 9, and x is equal to plus and minus 3. Okay, but we have to deal with only the solutions that are part of the domain, right? When x is greater than 2. So our answer here is going to be x is equal to 3. Okay, and that makes sense. Here it is. Here's 3. That's where the height of my graph is equal to 4. All right, so that's going to give you guys a little bit of a shot of what you need for the quiz. So it was kind of this analysis of a piecewise function and I guess building one. Okay, and then on page, what did we say that was? I lost it now. Of course, oh yeah, on page 28, those writing absolute values as piecewise functions. That should do you for the day. Just finish up the all of the exercises on N4-5 and the little handout that the substitute will give you. Okay, you should be set up. Good stuff.